press the bell icon on the YouTube app and never miss another update.
Today, we are going to discuss one of the important types of motion, that is oscillation. So far, we have discussed, right, motion of physical objects, right, while discussing the mechanics part of the physics, right. Now, oscillation is one of the types of motion. The study of oscillation helps us in understanding, right, the other type of motion, that is wave motion. A wave is a sort of disturbance produced in a medium, and the propagation of disturbance is called as wave motion. Wave and wave motion, their study are important because of the fact that they are one of the natural methods of transportation of energy from one place to another place. We know that in communication system, transformation of information and message, we are using microwaves, radio waves, etc. And even when we are talking with some other person, right, we transfer the message or information through sound energy. Sound is a form of wave that transfers information from, right, speaker to listener. To understand all these processes, we need to understand this oscillation. It may also called as a vibration, right. Now, to start with the oscillation, right, we'll take some basics, right. Now, physics, we are all already discussed. Physics is that branch of science which deals with the study of, right, nature and natural phenomena, right. And when it comes to the nature or the universe, now in the nature or universe, the things exist in two forms. The things exist in two forms. One is matter and the other one is energy, right. The two forms of the things, right, in the universe are matter and energy. Here, when we take matter, right, so matter is something having mass and occupies a volume in space whose presence can be felt through our sense organs. For example, here the chalk piece, it is a matter, it has a mass, it occupies volume in space, right. I can sense it through my sense organ. I can see this chalk piece and I can hold this chalk piece in my hand and I can feel that it is a matter, right. Now, starting from, right, electron, neutron, proton, nucleus, atom, molecule, solid, liquid, gas, a planet, a satellite, a star, a rocket, the Milky Way, right, galaxy, etc. are matter. We will take starting from electron to a star is matter, right. The matter has a mass and it occupies a volume in space. And another thing is energy. In nature, energy exists in different forms like sound energy, light energy, heat energy, right? Electromagnetic waves such as gamma rays, X-rays, ultraviolet rays, visible rays, that is our light, what we call, right? Infrared radiation, they are nothing but heat radiations, microwaves, radio waves, etc. Right? So in universe we can have electron, atom, solid, star, sound, light, heat, etc. Right? Now the entire things exist only in two forms. Now according to Einstein, matter and energy are interconvertible. Energy can be converted into mass and mass can be converted into energy, and of course, right, this is not the subject of this chapter. We will discuss that concept later while discussing atomic physics or modern physics, right? So anyway, so when we take the matter, we are actually in oscillation, and the next chapter waves we are discussing again the two forms, both matter and energy here. Therefore I am taking what exactly is matter and what exactly is energy. Now another important thing in the study of physics is motion. The important thing in the study of physics is motion. In fact, the branch of physics that deals with the study of, right, motion and rest of physical objects is called as mechanics, and mechanics is the oldest branch of physics, right? It was the study of mechanics has started much before Christ, right? And what exactly is motion? A body is said to be in motion, right? If it changes its position with passage of time with respect to, right, a fixed point called reference point, and an equivalent, another word, rest. An object is said to be at rest, right, if there is no change in position of the object with passage of time with respect to a fixed point, right? Say when I am standing with respect to the board, I am at rest here. Suppose I will move like this, then I am in a state of motion. And one more important thing is, there is no absolute rest in the universe, right? No material body is absolutely at rest, right? The term rest and motion are relative. We can say a body is at rest, right, or in motion with respect to a fixed point only. Let us see what exactly the relative motion. So when I take this board as a reference point, right, now I am standing before the board and not changing my position with respect to, right, the board with respect to time. Then, then I am at rest with respect to this board. But suppose, let us assume that an astronaut, right, in an artificial satellite is observing me. Then, for him, I am not at rest. I am changing the position. I am moving, right? It is because of motion of Earth. Earth has rotational motion on its own axis, right? The day and nights are results of that rotation. So I am rotating about the Earth's axis for astronaut. At the same time, Earth is revolving around the sun, right? Therefore, I am also revolving around the sun on surface of Earth. The astronaut can observe, right, two motions in me. So, we will say that motion is relative. With respect to astronaut, I am moving. With respect to this board, I am at rest, right? Now, starting from electron to a star, right, is always in a state of relative motion. Electron is revolving around the nucleus and also executes spin motion. Nucleus is also spinning about its own axis. Neutrons or protons are also spinning about their axis. Atom maybe in a state of vibration. Molecule may be in a state of vibration, right? In gases, it may have translational motion, it may have rotational motion, right? And even planet executes motion, satellites execute motion, stars also executes motion. Starting from electron to a star, right? A matter is always in a state of relative motion, right? Now, this motion in general, right, is classified into three types. There are three types of motion, right? Generalized three types of motion, right, depending upon their nature, right? Now, they are number one, translational motion or translatory motion. Number two, rotational motion or rotatory motion. Number three, oscillation or vibration, right? That is, we call oscillatory motion or vibratory motion. So, all motions in the nature, right, is one of the three: translational, rotational, oscillational, or sometimes they may execute simultaneously translational motion and rotational motion, right? But in this chapter, right, our main discussion is confined to oscillation motion or vibrational motion, right? In order to understand what exactly the oscillational motion or vibrational motion, right, let us understand what is translational motion and what is rotational motion along with some examples. Right. Now, we will take those motions one by one. That is, number one, translational motion or translatory motion. It is also called linear motion, right? The motion of a body is said to be translational if all particles or parts of the body, right, travel in parallel paths, right? Here, when I say that particles of the body, we know that every material bodies are made up of atoms or molecules. Whenever I say particles of a body, extended body, like a chalk piece, a ball, a rocket, a car, etc., right? Right, they may be different parts. When I will take a body, right, then particles means atoms or molecules, right? So we see, for example, right, a car moving on a road, right? A car moving on a road, right? When a car is moving on a road, right, different parts of the car, maybe the steering, maybe the gear, maybe the seats, right, maybe the doors, maybe review mirrors, all are moving, right, in parallel paths, right? If we take left side review mirror, whenever it is moving along a path and all other parts are moving in paths parallel to that one, such a motion is called as translational motion. We can take right now, so motion of a bullet fired from a gun. Now the motion of a arrow, an arrow shot from a bow, right? Motion of train, motion of cricket ball, right, etc., right, or translational motion. Translational motion is also called as a linear motion, right? Now the linear motion means it may be along straight line, it may be along a non-linear curve, right? Now translational motion may be along straight line or it may be along a non-linear curve. For example, right, a cyclist taking a turn, though he is not moving along straight line, but the motion is a translational motion, right, for a part. Right. Now the second one, it is rotational motion. Right. Now a body is said to be in rotational motion if a particle of the body or a line of particles of the body remain stationary or at rest, and all other particles of the body describe, right, circular paths about the axis of that particular particle or line of particles, right? For example, we can take number one, spinning of a top. You know that top means ಬುಗುರಿ ತಿರುಗಿಸೋದನ್ನು ನೋಡಿರ್ತೀರಲ್ಲ, ರೈಟ್? When we take a top, motion of a top, this is the nail on ground. When a top is moving, spinning, right, we say that it is spinning about an axis of rotation. Here we see that a line of particle passing through the nail and the center of gravity, right, always remain at rest, right, and all other particle, take a particle here, it describes a circular path about the stationary particle. When I take a particle at this point, it is also executing, right, circular motion. So when I take, say, earth rotating about an axis, now I have taken vertical axis. In practice, it is not exactly vertical, it is inclined at certain angle. Now this is represented like this, right? That means it is a spinning motion in anti-clockwise direction. So here, when I take this part B, particle A, particle B, and on every particle on that line AB are at rest. But when I say take a particle C, right, it is describing a circular path. Particle at D is again describe a circular path, of course of greater radius than C. And when I take the particle at D, it is also describing circular path. Such a motion is called as, right, rotational motion. When I take a clock, right, now when I consider a needle, say second needle, it is, right, moving in such a way that it's a point of pivot A that remains at rest, right, and all other particles, if I make some marking, right, marking 1, marking 2, marking 3, marking 4, they all describe circular path. Here, a particle of the needle A remains at rest, and the remaining particle describe, right, circular motion, right, about that point. Such a motion is called as, right, rotational motion. For example, we can take rotation of earth here planet around its own axis, and even if we take electron, it is spinning, right, it has two motion, just like a planet, orbital motion around the nucleus as well as spin motion, and this rotational motion is right, is one of the important motion here, right. But when we say that, when we take a bowler in a cricket match, he is bowling towards a batsman, then what is the type of motion associated with that ball, right? Now generally the ball will have two types of motion simultaneously. It has translational motion as it is moving from bowler towards batsman. At the same time it has rotational motion, right? So a ball bowled by a bowler in a cricket match has both motions, right, rotational motion and translational motion. To avoid, right, the confusion, that confusion means, right, to study both translational motion and rotational motion simultaneously, it becomes very complicated. Therefore, right, in mechanics we use the concept of particle or point mass. Particle or point mass, right? a particle is a point mass having only mass m and it has no dimensions such as no length, no area, no volume, right? It is just a point, right? Whenever we consider a point, single point, it cannot have rotational motion. It can have translational motion or oscillation motion, but it never exhibits, right, rotational motion, right? Therefore, often in the study of translational motion and oscillational motion, instead of taking a body, right, we consider a particle or a point mass, because a point mass is either executing translational motion or executing vibrational or oscillational motion. It never executes rotational motion. But when I take this chalk piece, it is not a point object, right? It is an extended object. When I throw it, it executes two motions, both translational motion and rotational motion, just like a cricket ball bowled by a bowler, right? Therefore, in the study of linear motion and oscillational motion, we use the concept of particle or point mass. But when we take rotational motion, we are not taking the particle, where we are taking an extended object called rigid body. We will discuss it in the other classes, right? Now, before going to oscillational motion or vibrational motion, we will discuss another type of motion, related motion, right? That is periodic motion. So generally, motions of physical objects can be classified into two types other than those translational, rotational and vibrational motion. There is periodic motion and non-periodic motion. A motion of a body is said to be periodic if it retraces its path again and again, right, at a regular interval of time. That regular interval of time is called as a period, right? Now, suppose, right, we take example, rotation of earth on its own axis, right? Now suppose we take earth is rotating, whenever we take a point A, it describes the same path repeatedly, circular path at a regular interval of time, and that is called right, period of rotation. And period of rotation of earth is approximately 24 hours. It is exactly 23 hours and 56 minutes. Number 2, revolution of earth around the sun. It traces elliptical orbit, right? It is retracing that elliptical orbit around the sun at regular interval of time, right? That time period of revolution of earth is 1 year, approximately 365 days, right? That is the revolution period of revolution of the earth, right? It is a periodic motion because rotation occurs once in 24 hours. One revolution occurs once in 365 days. Now the third one, right? Motion of simple pendulum, right? Or motion of bob of a simple pendulum, right? Is a periodic motion. Now, motion of a loaded spring. Right. Suppose if we have a spring, an ordinary spring, right, whose one end is rigidly fixed to a top and we attach a load of mass m to it. Of course, initially it gets stretched, the length of the spring increases. I am taking this equilibrium position, right? Now this position is at rest. So when I slightly pulled it down, it executes, right, up and down motion or to and fro motion, just like a simple pendulum. A simple pendulum consists of an object like a spherical bob. It may not be spherical or any object, right? Bob, right, connected to a fixed point through a light inextensible string. When it is, right, executing motion, right, it retraces its path again and again at a regular interval of time. Here the load attached to the spring when pulled executes a periodic motion. In all the cases, right, the motion repeats again and again at a regular interval of time called, right, period. Here it is period of rotation. Here it is period of revolution. In these cases, period of oscillation or period of revolution. So when we observe 1 and 2, there is a similarity. 3 and 4, there is a similarity. The motion of 1 and 2 is different from the motion of 3 and 4. Why? Because we see here, when a pendulum is oscillating, when it is retracing its path, it is a periodic motion, but it always passes through a fixed point here, right? While executing, right, repeated motion, it always passes through a fixed point, this point. Here also, this mass or load, right, during its motion, repeated motion, it passes through the same position again and again. But here there is no such fixed position to the point, right? Clear? Right here, the motion of this earth, or we take a body spinning top, is rotational motion, but the particles describe circular motion, right? Just like an electron revolving around the nucleus, right? It is a periodic motion, right? And this is not similar to the motion executed by simple pendulum or loaded spring, right? So we clearly come to know that a motion that repeats again and again at a regular interval of time, or a motion in which a body retraces its path again and again at a regular interval of time is called as periodic motion. What is a non-periodic motion? Suppose when we say that a bullet is fired from a gun, it will move from gun to the target, right? It will not repeat its motion. It will not retrace its path, going to the target, coming back to gun, again going to the target, coming back to gun. No, right? It will not happen. So it is a non-periodic motion, motion of a car, right? Of course, moving from one place to another place, right? Motion of a train, motion of a bullet, motion of an arrow, right? Motion of a cricket ball bowled by, right, a bowler, right? They are non-periodic motions, right? They do not repeat, right, or retrace their path again and again at regular interval of time. That is the difference between periodic motion and, right, non-periodic motion, right? Now we will take up that oscillational motion. Now we will take oscillation or vibration, right? Oscillational motion is also called as vibrational motion, right? Now a particle, here we are using that concept, we are not taking any body, we are taking particle, right? A particle is said to be in oscillational motion or vibrational motion if it moves to and fro or back and forth about a fixed point, right, at regular intervals of time, right? Now a particle is said to be in oscillation if it moves or executes to and fro or back and forth, right, about a fixed point at regular interval of time, right? Now a particle is said to be in oscillational motion if it moves, right, or executes to and fro motion or back and forth motion about a fixed point. This is very important, at regular interval of time. For example, we take motion of bob of a simple pendulum. Motion of a bob of simple pendulum. Now, a simple pendulum consists of a bob, right, suspended from a point through a string or thread. Here it is bob, say at position O, right. Now when there is no motion in the bob, right, when bob is at rest, when bob is at rest, then O is fixed point. Then O is called fixed point and it is called mean position or equilibrium position. This position of bob, suspended bob, when there is no motion in it, that position is called, right, fixed position, right, or mean position or equilibrium position, right. Now when the same simple pendulum having the fixed point O is slightly pulled apart and released, right. Now it began to move like this, right. When it is pulled to the point A, then it starts moving towards O, mean position, but it will not stop there. It will overshoot the mean position and comes to this point, say B, right. Again at B, it will not comes to the rest, right. So it will move again from B to A, passing through that mean position, and again from A it moves to B, right, again passing through that point O, right. Now we see that this simple pendulum is executing to and fro or back and forth motion about a fixed point. That means while executing to and fro motion, it passes through that particular fixed point. At the same time, it repeats the same path AOB, BOA, AOB, BOA, AOB, BOA again at a regular interval of time. Now we see that periodic motion, a motion that repeats again and again at a regular interval of time is a periodic motion. So here the motion of a simple pendulum, it is a periodic motion. Just like an electron revolving around the nucleus. Here, what is the similarity between electron revolving around the nucleus of an atom and simple pendulum? Both are periodic motion. They retrace their path again and again at a regular interval of time, right? But it is called oscillation. It is periodic but not oscillational because it has no mean position. It has no position at rest. Here it is the position at rest, right? Let me see here. It is executing to and fro motion, that is repeated motion, retracing its path again and again about a fixed point, right? Therefore, that is the difference between the motion of an electron, which is periodic, motion of a simple pendulum, which is periodic, but it is called oscillational motion, right? Essentially, oscillational motion is a periodic motion, but all periodic motions are not oscillation or vibration. For example, rotation of earth on its own axis, revolution of earth around the sun, right? Spinning of a top, motion of electron around the nucleus. They are all periodic motions but not oscillational motion because they do not have a fixed point about which the motion repeats, right? So, is that clear? Right. By definition, a particle is said to be in oscillational motion if it executes, right, to and fro or back and forth, right, motion about a fixed point at regular intervals of time. This fixed point is missing in, right, periodic motion. In oscillation, there is a periodic motion, at the same time there is a bounded motion, right? Again, when we take a simple pendulum, this position O, it is called mean position. When it is executing motion, say this is position A, this is position B, it is retracing, right, the path AOB again and again at regular interval of time. Now here O is mean position, this is one extreme position, this is the other extreme position, right? Here the positions of the bob at A and B are called extreme positions, right? Now, whenever we pull the bob up to A, right? Now, say some 10 centimeter away from O, Here also it will go 10 centimeter away from O towards B. On either side of OA is 10 centimeter, OB is also 10 centimeter. It will not go beyond A and beyond, right, that B. So, point number 1, the fixed position or point is called mean position or equilibrium position. Mean position or equilibrium position. Point number 2, the motion is right within well defined boundary between two extreme positions, right? That means it is a bounded motion. We say that it is a motion is bounded within the 2 points A and B. It will not go beyond A and beyond B. That means it is a right bounded motion. Third one, it is a periodic motion. That is most important. It is a periodic motion. It retraces the same path again and again at regular intervals of time. Therefore, it is a periodic motion. Right now, we can say that thus a periodic and bounded motion about a fixed point is an oscillation. Is an oscillational motion, right? So clearly, an oscillation is a periodic and bounded motion about a fixed point. But see the rotation and revolution, they are periodic but not bounded, right? So here a periodic and bounded motion about a fixed point is called an oscillational motion or vibrational motion. There is no much difference between oscillational and vibrational motion. It's all under situation. The motion is called oscillation. The same motion under other situation, it is called vibrational motion. We will discuss it after discussing some basic terms like frequency. Now, we take the case of a loaded spring. Because in this chapter, we will discuss both oscillation of a simple pendulum as well as oscillation of a loaded spring. Now this is the mean position O. When it is pulled to a position say A. Now in motion it will move to the position B. Here it is executing to and fro motion along AOB, right. So here also O is mean position, A and B are two extreme positions on either side of the mean position. So the motion is, right, confined within two well defined positions called extreme positions on either side of the mean positions, right. Therefore it is a bounded motion. Right. So this is loaded spring. This is simple pendulum. Again here O is mean position, A and B are extreme position. Now it executes motion along, right, AO, B and BO, A. See here path is a straight line. Now the path retraced by loaded spring is a straight line. Here path is a curve, right. In a loaded spring, the path traced is a straight line, but in a simple pendulum, the path traced is a curve. Now we will take some basic definition, right, by which we can understand the oscillational motion. So basic definitions. Number one, oscillation or vibration. Now, one complete to and fro motion of a particle, right, is called oscillation or vibration. Sometimes it is called as a cycle. So, one complete to and fro motion, right, is called oscillation या vibration, or sometimes it is called as a cycle. Again, when we take a simple pendulum, right, right. So when I starting from A O B to motion, B O A flow motion, right? So one complete motion A O B O A, that constitutes one oscillation starting from A to B and from B to A constitutes one oscillation. Or when we take this O is starting point, motion from O to A, B to A and A to O constitutes one oscillation, one vibration. Sometimes it is called cycle. Number 2, period of oscillation or period of vibration. It is generally denoted by T. Now, the time taken by a particle to complete one to and fro motion or one oscillation or one vibration is called a period of oscillation or period of vibration. Right. Now it is time taken to complete one oscillation is called period of oscillation, right? Now, how to calculate the period of oscillation, right? Can we take a timer, right? When we start the timer, when Bob is at position A, then when wait to go to the position B and come back to the position A, now close that watch. Then that time interval gives the period of oscillation. Generally, while finding period of oscillation, we cannot consider only one oscillation, right? Time, right, for measured for one oscillation, right? Of course, by definition, it is the time taken to complete one oscillation, but by measuring we cannot take only one oscillation because there may be error, because the time may be consumed in oning the watch and offing the watch, right? That is the watch clock. Therefore, when we measure the time period, that time period is equal to, so time taken for n oscillation divided by number of oscillation, right? So time period is equal to time taken for n oscillation divided by number of oscillation. Suppose T is equal to, right, it is T by n, where T is the time taken for n number of oscillation and n is the number of oscillation. Suppose if a simple pendulum takes, right, 30 seconds for 15 oscillation. that divided by number of oscillation 50, right? That means the time is equal to 30 by 15, that is equal to 2 hertz. That is 2 hertz. That means that simple pendulum takes 2 seconds to complete one oscillation, that is going from A to B and from B to A. It takes right, oh, sorry, not hertz, it is 2 seconds. 2 seconds. Now the SI unit of period is a second. Here for this simple pendulum oscillation, right, the time period is 2 seconds. Don't think that a very simple pendulum has the time period of 2 seconds. No, it depends upon several factors. We will discuss it later. For a given setup, a simple pendulum of given length at a given place, right, now it has a constant, right, period, that in this case what we have taken, the time period is equal to 2 seconds. Now the third one is frequency, generally denoted by F. Now the frequency of oscillation is the number of oscillations completed in 1 second. Now frequency of oscillation is the number of oscillations completed in 1 second. Right. Now the SI unit of frequency is hertz. SI unit of frequency is hertz, and its symbol is capital H small z. So generally, right, the frequency can be calculated by using this formula. Frequency is equal to, right, it is the number of oscillations by time taken. Frequency is equal to number of oscillations by time taken, or F is equal to N by T, where N is the number of oscillation, right, and T is the time taken, and this F is equal to, can be written as 1 by T by N, where T is the time taken for N oscillation divided by N oscillation. Therefore, F is equal to 1 by T. That means frequency of oscillation is equal to the reciprocal of time period, or time period is equal to the reciprocal of frequency, and that is the relation between, right, frequency of oscillation and period of oscillation. Suppose if we know period, then we calculate period of oscillation, or if we know period of oscillation, then we calculate the frequency. So frequency and period, right, are related to each other, and these two are very important terms, right, in understanding oscillational motion, right. We will right conclude at this stage, I mean concluding this class, and we will continue in the next class, taking right next up right terms like displacement, amplitude, angular velocity, angular frequency, etc. Thank you very much.